Okay, let's take a look at a few of these. Remember that the answers on approaches, you have multiple choices. So, like on number 4, you can choose to cancel out the x's by multiplying by 3. But you can also choose to cancel out the y's by multiplying the bottom here by 5. So you have to pick a variable and go with it. Sometimes it's easier to cancel out one variable than another. Other times it's the same amount of work either way. But you will get the same answer regardless. 0. And for right now we're just stopping at the elimination step. So we get 0. 9 times what equals 8 minus 8 is 0. So I get x equals 0 here. 9 times 0 is 0. Here again we can cancel out x or y, but we have to choose a variable to go with. After a while, this becomes pretty normal, pretty routine. There we go. Alright, let's flip it over to the back. Just to remind you about the no solution in the infinite, that you get a no solution when you have something false left over, and here something true. Now, both of these require both variables to be canceled. So this only happens if you're doing this method and both variables cancel out. So for instance here, what's the smallest number, let's say, that both 8 and 12 go into? What's the smallest number that both 8 and 12 go into? And you'll come up with? 8 doesn't go into 12. 8 and 12 go into what number? 24. Oh, okay, yeah. So we need to multiply the top by 3, the bottom by 2. That'll give us a negative 24 on top, positive 24 on the bottom. So let's write that out all the way. So here we have the case where both variables end up equaling 0. 12 minus 12. And 24 minus 24. And actually 12 minus 12 on the right-hand side. So the left-hand side equals 0. So does the right-hand side. So this is a true statement. So we end up with infinite. Okay. Because what's left over is true. And with equations, it's the same thing to say that the left and right-hand side are the same. and 13 would be like the other example. So what's the smallest number that both, let's say, 25 and 30 go into? A little more difficult. Alright. So play with it a little bit. You'll find out that these both go into 150. So if you multiply the bottom one by 5, this will give you 150y. Multiply the top one by 6, this will give you negative 150y. So you go for the smallest number. Don't go for just the product of the two numbers themselves. So we'll get negative 90x minus 150y equals 24. And on the bottom we'll get 90x plus 150y equals negative 30. And just like above, both variables cancel out. That equals 0. And the right-hand side equals negative 6, which is a false statement. 0 does not equal negative 6. Therefore, there is no solution. Anybody venture a hypothesis of what would happen if we graphed these two lines? What would it look like if there's no solution? What would it look like? I heard someone say it. They're parallel. Yeah, I'm not sure if they're both positive slopes like this, but remember, no solution doesn't mean you can't graph. No solutions means there's no intersection. Okay, the answer is where they intersect, so if there's no answer, there's no intersection. The only way for two lines not to intersect anywhere is if they're parallel. So do not confuse no solution for, well, that means you can't graph. It just means they don't intersect. There's no breaking point, they call it. No break-even point. Okay, so, and then we have more of these, very similar to what you just did, just change the type of question from types of pies to types of tickets. So, very similar. Let's figure out what kind of variables we want to use. We can use like S for senior citizen and use C for child, and then you can go ahead and write your equations. So 2 senior citizen tickets plus 5 child tickets, total of $51. And then we have 14 senior citizen tickets and 11 child tickets for $141. So it'll end up very similar to the questions you've already done. Okay? Alright, so these are just the notes for us to get used to this. That's why I only wanted you to write out the equations and set them up and not solve them all. If you went and solved them all anyway, that was up to you. I'm going to pass out the homework right now. I'm going to check both homeworks, the weekend's homework and this homework, at the end of class tomorrow. So you have a little bit of time in class to work on this.